This is the tutorial for the problem solving connections part 2, and so what they're doing here is they're asking us to find the length of one of the sides of these small rectangles. And these small rectangles are supposed to be planter boxes. This is the garden area, and we're putting these 6 planter boxes into this garden area, and we're trying to find out some information about how long these boards are. We know that the width of the board here is 5/6 of a foot. We just don't know what the length is, and that's what they're asking here. So we have 6 identical rectangles are inside the large rectangle, and each small rectangle is 10 inches or 5/6 of a foot. That's what it says. The distance between the rectangles is 14 inches, and so that's 1/1/6 of a foot, and that's what this distance here says. And so we see that there are 14 inches or 1 1/6 between each of these rectangles and then also on the sides. And it asks us to find the length of x, which is the length of the small rectangle. So we're going to go ahead and set up a little equation, and the one I'm going to do goes this way to start with. We've got 1 1/6 plus x, and so I'm doing this distance here plus this distance, and then I'm going to add another 1 1/6, because I haven't made it all the way across yet, plus another x for the length of the unknown length of that smaller rectangle, plus another 1 1/6, and then I have that last x. And so go ahead and write in a plus another x there, and then one more 1 1/6, and then I've made it all the way across. See, 1 1/6, I got x, 1 1/6, x, 1 1/6, x, and 1 1/6. And the entire distance is given to us. It says it's 9 1/12. So now I'm going to use a little multiplication rule here, which says that if I have repeated addition, I can multiply. And so that's what I'm going to do. 4 times 1 1/6. I also have some x's that are all being added together, so I can write down that as 3x, and this all equals 9 1/12. So now I have to use some multiplication to come up with what 4 1/6 it multiplies to make. So 4 times 1 1/6, that is. So I'm going to change that 4 and 1, or 1 1/6, to an improper fraction. That'd be 7/6. So all I did is just do 1 times 6 plus the 1, made the 7 over the denominator of 6. So now I go ahead and multiply, and I end up with 28/6 plus 3x equals 9 1/12. So now I need to change this back into a mixed number, and that's going to end up giving me 4, and I have 4 left over. 4 and 4 6. I could reduce that, but I'm not going to. And the reason is that I'll need to come up with a common denominator anyhow in the next step. So my next step is to move that 4 and 4 6 back to the other side. So when I do that, you see how the denominators are not the same, so I need to change them. So I'm going to end up multiplying the 12, actually the 6 here, by a 2 over 2. That's going to give me 8/12. But you see how when I try to do the subtraction, 1 minus 8 gives me a negative number, so I need to borrow. I need to borrow from the 9, change it to an 8, and then add 1 to the 1/12. So I'm going to write 1 as 12/12, so I can add it to the 1/12. That gives me a total of 13/12, and now I can go ahead and subtract these numbers. So 8 minus 4 gives me 4, and then doing that subtraction I get 5/12, and this all still equals 3x. So now we need to divide by 3, and so the way we're going to do that is we're going to multiply by the reciprocal. And this does the same thing. You see how the 3 is the same thing as 3 over 1. The 3's will end up cross-canceling. Do the same thing on this side. So I'm multiplying by the reciprocal on both sides. So now what I need to do is I need to change this 4 and 5/12 to a improper fraction. So 4 times 12 makes 48, plus the 5 gives me, let's see here, 48, and I have to add that 5, and that's going to give me 53. So 53 over 36, and I got that by doing the 12 times the 3 at the end. And so let's go ahead and change that back to a mixed number. So again, I got that 53 over 36 by doing the 48. Go ahead and erase these little marks here. So I had the 48 plus the 5 made 53 all over the 12, and then times by a third, and you can see I'm getting 36 there. So I've changed that back to a mixed number, and I'm dividing 36 into 53, and it's only going to end up going in there one time, and then I do the subtraction and a little bit of borrowing, and see, that'll end up giving me 17. So 1 in 1736 is the length of each of those boards, and those are in feet. So moving on to the next one, it says to find the perimeter of each small rectangle. So now what we want to do is we're breaking this into parts. Again, eventually we want to find out how much wood we need to be able to build these. So now we found the length x here. So now we're going to find the perimeter. So I know that each of the sides, or the sides opposite of the ones I see there, are the same. So I can do the perimeter as the 2 double the 5 6, and then I can add on doubling the 1 and 17 36. So another way to do this, since we're doubling both numbers, we can use the distributive property, and that's when we take that common factor and pull it outside some parentheses and then add the two numbers that are going to end up being different in this case. And that'll give me the perimeters. Well, it might be a little bit easier, so I need to come up with a common denominator. So I'm going to go ahead and multiply that 5 6 here by 6 over 6, and that gives me 30 36 plus the 1 and 17 36. And still I'm going to add those together and multiply that by 2. So I have to add the 30 and the 17. That gives me 47. So 47 over 36. And I have 1 and 47 36, and that's going to be the perimeter. However, I still need to take that and multiply that number by 2. And so at this stage right now, we can go ahead and change this to an improper fraction. So this is not quite a proper mixed number, but that's okay because we need to change it to an improper fraction anyhow at this stage. So 1 times 36 makes 36, and then you got add 47. So that gives me 13. And then I have to add these numbers, and that gives me 7 and 1 make 8. So 836 times by 2. I got to double that number. So think of the 2 as 2 over 1, and then go ahead and do some cross canceling. So 2 goes into 36 18 times. And now we have 18, or 83 18ths. And so we'll use that number again, so that's why I wrote it down. That equals the perimeter, but we're going to do some division here. And we're going to change this to an 8, 83 here. So 18 goes into 83. So we have, let's go with 4 times. And that makes 32. And 3 plus 4 makes 7, so 72. And that leaves me with 11 left over. So 4 and 11 18ths. And that's going to end up being the perimeter that we're going to end up having for one planar box. So now the question is going to be, well, if that's the case, we want to find out what the length around all of the planar boxes is. So instead of doing that again, so here this one's 4 and 11 18ths, 4 and 11 18ths, 4 and 11 18ths. See, we have 6 of them to do. So instead of adding up 4 and 11 18ths 6 times, since we have 6 of them, they want to know how much all the wood needed to make these planar boxes is going to be. So we're going to take 6 planar boxes, or we'll say 6 boxes, and we're going to multiply that, multiply by the perimeter. And so we have 6 times by 4 and 11 18ths. So from this point, what we need to do is we need to change this back to an improper fraction. That's why I said keep that improper fraction there. Write that down because we're going to use it again. 83 over 18 and then times by 6 over 1. So we go ahead and do some reducing. So we'll cancel out the 6, the 18 there. That becomes a 3. So now we got 83 thirds. And we might end up using that again too. So hold on to that number. And we do some division. So we're trying to find all of them here. So 3 into 8 goes 2 times. 6 with 2 left over. 3 into 23 goes 7 times with 2 left over. So 27 and 2/3 feet. That is how much wood we're going to need for all of the planar boxes together. So then they move on and ask us some other questions. And let's check out what they say here. It says the board feet, or the boards only are sold in 12-foot lengths. How many boards will we buy? Well, if we have, let's go back to how many we had there. So we had 27 2/3, which was 83 thirds. That's what we needed there. So 27 2/3 feet. And we're going to divide that by 12 to find out how many goes in there, how many times. And so remember I said, oh, it might need that improper fraction form again. Let's go back to that. 83 thirds was what that number was. So we're going to use that again. And we're going to divide by 12. So remember, it's 12 over 1, but we're going to end up multiplying by the reciprocal. And so we end up multiplying across, no cross canceling there, so we have 83 over 36. So now we just have to set up the division problem. And when we see 36 goes into 83 two times, that makes 72. And do a little subtraction. We have 2 and 11 32nds. So we're going to need more than 2 boards. We need more than 2 boards. And so what we'll end up doing is we're going to buy 3. Oops, I'll kind of buy there. Change that to a U. Buy 3 boards. So now, what they're going to do is they're going to say, well, it costs $1.75 per foot. How much is it going to cost for all the boards? So we're going to take $1.75. Now, per means division. So per foot. And we're going to multiply it by the number of boards that we're going to end up buying, which was 3 boards. And we're going to say that each of these boards now is going to be 12 feet. So 12 feet per board. So we've got 12 feet times the number of boards, and then times by the $1.75. So that makes $1.75 times 36. Now I have the 36 by multiplying 3 and 12, and then I just do the multiplication. So it makes 30. 42 makes 45. That makes 10. Carry a 0 and do it again. We have 15, and it makes 22, and carry a 2, and that makes 3 and 2 make 5. And then we add this stuff up, and we have to carry, and we end up with 6. So $63 is the cost of all of the boards to make up those 6 planter boxes.